Good evening and welcome to the next in our series of how to get better at maths C3 and C4. Hopefully you'll see the chat is live. I'm just going to type something in it just to make sure things are working. Someone can respond. Okay, so we now got the chat working and we can see that's working. Let's crack on with our first in our series of questions. Our first question will be, let's just get this out of the way, will be this one, not this one. We're going to start off with a bit of trig. And we're just going to look at, so before we get into this question, so I just wanted to go over other things you need to make sure you know in trig. There's very few past questions on this, but there are just a few every now and then. So you do need to make sure you know all these facts here about inverse trig functions. You need to know the range, the domain that they are valid for and the range which they are valid for. Okay, and the tricky one is cos, because it starts at 0 and goes all the way up to the pi for the domain, whereas both the other two are minus pi to pi by 2. So just make sure you know these. This is here for you to check and test yourself on, because it is quite important you understand and know these functions. Although I've been looking at past paper questions and they've only come up twice in the last 8 years, but you still need to ensure that you know this. So let's just crack on to our first question, which is quite a tough question and it's quite hard to fit on the screen. I can just about zoom in as much as I can. It's quite a tricky Rcos x plus alpha type of question. So I'm going to give you, what's that? It's going to be 3, 5, 6. I'm going to give you 10 minutes to have a crack at that to start off with. If you're struggling to read it, I'm going to read it through. It says, Kate crosses a road of constant width 7 meters in order to take a photograph of a marathon runner, John, approaching at 3 meters per second. Kate is 24 meters ahead of John when she starts to cross the road at the fixed point A. John passes her as she reaches the other side of the road. A variable point B is shown in figure 2. Kate's speed is v meters per second. She moves in a straight line, which makes an angle theta, where theta is between 0 and 150 degrees, with the edge of the road as shown in figure 2. You may assume that v is given by this formula, 21 over 24 sine theta plus 7 cos theta, where theta is between 0 and 50. First question, express 24 sine theta plus 7 cos theta in the form r cos theta minus alpha, where r and alpha are constants. R is greater than 0 and alpha is between 0 and 90, giving the value to 2 decimal places. Right, you need to be aware that the stream's lagging me by about 15 seconds at the moment. What I'll do is at the end of each question, I'll stop the stream temporarily for those 15 seconds to allow us to catch up at the start of every question. So I'm just going to move this over so it's a bit smaller, so I've got some space to do some working. And the first thing we've got to do is we've got to express 24 sine theta plus 7 cos theta in the form r cos theta minus alpha. So what I'm going to do is I'm going to expand r cos theta minus alpha. As you get better at this, you will probably take some shortcuts, but I'm definitely going to make sure I'm going to write a table out. So r cos theta cos alpha plus r sine theta sine alpha. And the trick to this is always to make sure you match the right things up. So I've got my cos theta here, and I've got cos theta here. So the 7 will be equal to r cos alpha. If you always write them out like this and match them up properly, you shouldn't have any problems with this question. So the sine thetas match up there. So therefore the 24 will equal r sine alpha. And I can write these two out. So I know that 24 will equal r sine alpha, and I know that 7 will equal r cos alpha. So if I do square them and add them together, you should realise that r squared equals 24 squared plus 7 squared. It's always equal to those two things. The reason being, if you square the left-hand one, you get 24 squared equals r squared plus sine alpha squared, and 7 squared equals r squared plus cos squared alpha, and you add them all together, you can take out a factor of r squared, and the sine squared plus cos squared equals 1. So you get to here. So we know that r squared is equal to that, which comes out to be 625 when you put it through your calculator. So therefore r equals the square root of 625, which is 25. Now, if we divide this equation by this equation, we'll get 24 over 7 is equal to r sine alpha over r cos alpha. And we should cancel that out to leave us just tan alpha equals 24 over 7. And if you do that, do shift tan alpha of that, you should get 73.74 degrees to 2 decimal places. Now, the next part of the question, here we go, we've got to find the minimum value of v. Now, if we know that v is equal to 21 over 25 cos theta minus 73.74, we can work out the minimum value of this is, because we know that theta is between 0 and 150. We don't need to use any calculus to do this. We can do this really straightforwardly. Because we know that theta is between 0 and 150, then theta minus alpha, okay, is going to be between minus 73.74, and take that off that and we get about 76. Okay, and what we do know is that cos, from minus 90 to 90, is always positive. So therefore the minimum value is going to be when cos of all of this equals 1, because cos can't be bigger than 1. So therefore, if cos can't be bigger than 1, then the biggest value we're going to get at the bottom is 25. So the minimum value of v will equal 21 over 25. And that's certainly a lot quicker if you can realise that and spot that. But it's not necessarily an easy spot, okay? And I can understand why some students might try using calculus to do that. Right, the next one, given that Kate's speed has the value found in part B, find the distance AB. So we want to find this distance here, given that the speed that she's been running at 21 over 25. So therefore, we know that theta must equal alpha for this to be the case, because at 0, theta equals alpha. So we know that theta equals alpha, so therefore the distance must equal 7 over, this is going to be 73 degrees in a bit. What was it? 73.74. So that's theta. We know that that distance there is 7. So we've got this triangle 7, we've got 73, we've got a right angle here, and we want to know the distance there, d. So therefore, that's the hypotenuse, that's the opposite. So we've got sine theta equals sine of 73 equals 7 over d, so therefore d will equal 7 over the sine of 73.74. And we work that all out, and you get 7.2916, or if recurring, or if you've got a fractional calculator, you might get 175 over 24. Now, given instead Kate's speed is 1.68, find the two possible values of angle theta given that theta is between 0 and 150. So therefore we know that 168 must equal 21, that's V, over 25 cos, just write that better, cos theta minus 73 point, all that business. So let's just rearrange this equation. So therefore we're going to get cos theta minus 73, I'm just going to shorten that to 73 for now, equals 21 over 25 times 1.68. And that comes out to be 0.5. So cos theta minus 73 equals 0.5. So therefore 0 minus 73 equals minus 60, or 60. And you add on 73 to both of those, we get 13.7 to add it onto the minus 60. Add it onto the 60, we get 133.7 degrees. Right, I'm just going to pause that for a few minutes to see if there's any questions on that and just check the stream's caught up. You have got to the final answer now, so I've not seen any questions. So I'm going to just temporarily stop the stream before we move on to the next question, and I'll restart it in about 10 seconds. Right, starting the stream up again. Here we go, and I'm going to give you, I've forgotten how many marks this was worth. It feels like an 8-mark question. I'll give you about 6 minutes to have a go at this. It's not a terribly long one to have a go at. So let's give you 6 minutes. If I can see if you're all finished, just send me a message to say you finished, so I can then start the question early. I can see how many people are watching. Off you go. Right, let's have a look at this question. So we want to find the first four terms in ascending powers of x. So the binomial expansion of 2 plus x to the 4 to the power of 10. Now we're going to use the expansion of 1 plus x to the n, which is equal to 1 plus nx plus n brackets n minus 1 over the natural x squared, and so on for all our expansions, because it makes life a lot easier. You can actually just use this with a standard binomial we got in C2 because this is an integer power. So it's quite a good warm-up for the question we're going to do. I got this off the International A-level paper. I'm surprised it had just a nice, easy integer power, but we'll use this to practice this question before we go on to question 2, which is a bit trickier. So if you're going to take the 2 out, then you need to take 2 to the power of 10 out. Okay, and that will leave you 1 plus x over 8 to the, so we get 2 to the 10. Right, I'm sorry. It seems my stream cut out early on the last question. So I'll just put the final answer to my last question up, explaining that what I do is I made the 2 plus x over 4 equal to the 0.25 here, okay, because that's what the expansion involves. Okay, so therefore if I make that equal to 2.025, I can find out what my value of x needs to be to put in the expression. And I take this value of x and I put it everywhere in the expression, and then I work out what I get, and it comes to this answer. Now the stream should be working a bit better now. Just check this, for those of you who are technically minded, the connection's improved from 0.19 megabits to 30 megabits. So hopefully we'll get through this part of the video without too much buffering. Right, we want to expand this first of all. Okay, so we're going to expand 1 plus ax to the minus 3 using the same formula as I had before. So I'm going to get 1. There's no need to do any dividing because I've got a 1 at the beginning, so I don't need to do anything clever at the beginning. So I got 1 plus minus 3 times by ax plus minus 3 times by minus 4, because it's n minus 1 for the next term, over 2 times ax squared plus minus 3 times minus 4 times minus 5 times by 3 over 2. I'm just going to make it a little bit smaller to fit that in. And then I'm going to get times ax cubed. So that gives me 1 minus 3ax plus, cancel that out with that to leave just 2. So that's going to be 6a squared x squared. Minus, just doing a bit more cancelling, saves ourselves some time, cancel that with 2 there, so that gives us 10. And you've got minus times a minus, 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 so that gives us minus 10. A cubed, x cubed, and plus all the rest of the terms. Now, to do the next bit, we've got to look at f of x, and the series expansion of f of x, the coefficient of x squared, is 3. So, in this series expansion, what we're going to do is we're going to realise that this bit here is just this bit brought up, isn't it? So you've got you're dividing by 1 plus ax cubed, which is the same as timesing by. Same as timesing by 1 plus ax to the minus 3. So we could write f of x. It's not approximately equal to it. It is still equal to this when we times by 1 plus ax to the minus 3. But what we're going to do is it's going to be approximately equal to the expansion of 2 plus 3x times, and then we're going to times by all of this, because we've got this as our approximation to this. So we get 1 minus 3ax plus 6a squared x squared minus 10a cubed x cubed plus all the rest. Now, for the next bit, we know that the coefficient of x squared is equal to 3. Now, we don't need to multiply the whole of this out to do the rest of the question. We just multiply the bits we want. So to get the x squared, we need the 2 times the 6a squared to get us how many lots of x squared. And we need the 3 times the 3ax, because 3x times 3ax will give you an x squared as well. So 3 will be equal to 2 times 6ax squared, which is 12a squared, and then we've got the 3 times the minus 3a, so it's going to give us minus 9a. So let's just get that all into one side. So 12a squared minus 9a minus 3. Actually, we're going to cancel down by 3. There's a factor of 3 here, here, and here. So we're going to get 4a squared minus 3a minus 1 equals 0. Factorise that. And we're going to get 4a, a, and we're going to have 1 and 1. Where are we going to put the minus? We're going to put it here to make sure we get a minus 3a. Just undo that little bit so it doesn't confuse. Oops, too many undos. So, and we're going to get our plus here. So either a equals minus a quarter from here, or 1. But we know that a is less than 0. We go back to the question. We can see that a is less than 0. So therefore a equals minus a quarter. Now we want, next part of the question, it asks us to find the coefficient of x cubed in our series expansion, giving your answers a simplified fraction. So we're going to have to work in fractions. Much better. And if you've got a calculator that works in fractions, then that life will be easy. So let's just do the x cubed bit. So we don't know what the coefficient of x cubed is. So the coefficient of x cubed is going to equal, I'm just going to circle this. So we're going to have the 3x times the x squared bit to get an x cubed, and we're going to have the 2 times by the 10a cubed to get us our x cubed bit. So that's going to give us minus 2 times 10a cubed plus 3 times 6a squared. So that's going to equal minus 2 times 10, and we've got a cubed, so that's going to be minus 1 over 4 cubed. Right, we've got 2 times 10 is the same as 2 times 5, so we can cancel out a 2, and one of the 4's leave me squared. So that's going to give me a minus as a minus, that's going to be 5 over 16 plus 3 times 2 times 3, what we've got going on here, and we've got that, actually it's not really going to help actually, times 1 quarter squared is going to be, minus a quarter squared is going to be 1 over 16. So we're going to get 3 times 3 is 9, times 2 is 18, so plus 18 sixteenths. So that is 23 sixteenths, and we're not going to be able to cancel that down, so that will be our answer for the coefficient of x cubed. Right, so that's a bit of a trickier binomial question. Just make sure you're careful when putting out your powers on binomial questions, and previously also be careful with the fractions. Very easy to make mistakes there, and don't forget to, when you take a number out, to raise it to the right power. Now I'm just before I sign off, I'm just going to go back to a question earlier which I left, this one, and just talk a little bit more about it, and just remind you of the important, this is from the famous C3 paper, where I think 70% of the marks gave you 100 UMS for this paper. And the key thing of this is always just to remember that in this part of these types of questions, just remember that cos theta or cos of anything, doesn't matter what's in here, goes between 1 and minus 1. And similarly for sine theta, if you get the sine version, you go between 1 and minus 1. And if you always write them out and always match them up, then you're less likely to make mistakes if you try and remember it by formulae. Okay, I'm always a big fan of writing them out, matching them up. Yes, you can take a shortcut to find r squared because that always works. But if you're not careful with your signs, things can go drastically wrong with the tan alpha if you don't match them up perfectly. Hope you found those useful. You've got some further questions in here. If you click on here, all right, in the trigonometry part, I've put an Adobe and a Word document in there. There's more r cos x plus alpha type problems. And if we go to the C4 section, I've also done some more binomial ones, and I put some international A-level questions in there as well as some standard A-level questions. You can choose which ones you fancy taking on.